Hello, my name is Saket Prajamanchai, number 4 from class 611.
Hello, my name is Sanawat Law, number 5 from class 611.
Hello, my name is Walashai Shaisukaji from class 611, number 6.
Hello, my name is Popton Damosakun from class 611, number 30.
So there are two main types of electrochemical cells, galvanic cells and electrolytic cells. The galvanic cell produces electricity by converting chemical energy into electrical energy. For example, zinc anode and copper cathode connected through a salt bridge in the diagram. The zinc undergoes oxidation, releasing electron, while copper undergoes reduction, accepting those electrons. The flow of electrons generates a current. Galvanic cells are crucial in powering everyday devices like flashlight and phones. Secondly, an electrolytic cell does the opposite. It uses electricity to drive chemical reaction that wouldn't happen on their own. For instance, electrolytic cells shown split water and salt NaCl into hydrogen and chlorine gases. This process is essential in industry for coating objects through electroplating or producing substances like hydrogen gases.
Okay, so let's compare and contrast electrolysis and galvanic cells. So electrolysis is an electrochemical reaction that requires the use of an external battery to make a spontaneous chemical reaction, while galvanic cells uses the energy from a spontaneous chemical reaction to generate energy. So for medical appliances, electrolysis can be used to make medical disinfectants such as electrolyzed water, or can also be used to deliver medicine gradually at a disease site through the skin, for example. Now, for galvanic cells, it can be used as a battery to power medical appliances such as medical pacemakers, or used as a biochemical sensor that monitors biomarkers.
Next, comparing between electrolysis and galvanic cells. Focusing on electrolysis, the electrolysis requires a battery to pull out the electrons. However, galvanic cells could turn from chemical energy into electricity by itself. In terms of cathode, the cathode in electrolysis was negative. However, in galvanic cells was positive due to its role. And the solution in electrolysis could mix together and create a redox reaction immediately. However, the galvanic cells cannot do that because they need to separate two solutions and connect the circuit by using salt bridge.
On the slide, we have a diagram of an electrolytic cell, a setup that uses electrical energy to drive a chemical reaction. At the top, there is a battery or power source. This provides the energy needed for the reaction to happen. There are two electrodes, the anode or the positive one and the cathode, the negative one. They help transfer electrons during the reaction. Electrolyte solution, this usually water with added salts, allowing ions to move freely and keep the reaction going. Example reaction, a common example is splitting water into hydrogen and oxygen gases. When the power is on, water breaks down, oxygen forms at the anode and hydrogen at the cathode. The setup shows how we can use electricity to drive chemical reactions, like producing hydrogen and oxygen from water. It's a key to process in many industrial applications.
Electrolysis in dentistry, electroplating dental appliances, objective, reinforce the scalar by electroplating with titanium. So my role as an experimental scientist is a hands-on and also detail-oriented. It's all starting with setting up the equipment needed for the experiment, like the electrolytic cells that are shown here. This setup is critical because it forms a foundation of the entire experiment. And after setting up, the next step is to carefully control and record all the variables involved. This means paying close attention to things like temperature, voltage, time to make sure that the experiment stays consistent and reliable. Monitoring the process is another big part of this role. I need to observe the reaction happening at both the cathode and the anode, as shown in the diagram. These reactions are key to understanding the experiment outcomes.
So for my test as a material scientist, so I am going to be tasked with testing different materials such as titanium, stainless steel, etc. for the effectiveness as a dental plating material. I will have to record all different material properties and all variables related to the testing process. I also have to test if it damages the tooth enamel when scratched. So this is the chart where we see the hardness of all the material. So I have to test all of that and I will have to record all of it.
Next is my role. My role is data analysis. The task is to analyze all property, including quantitative and qualitative data, and also compare the benefit and defects of different material, and calculate all price and feasibility of mass producing patent for wholesales.
Let's talk about my role as project manager. I manage all aspects of the project, including overseeing the procurement of equipment and materials to ensure we have everything needed to move forward efficiently. Another key part of my role is pitching ideas to partnership companies. Collaboration is crucial, especially when manufacturing a patent product.